So today, on the second part of the lesson from 7.3, we're going to learn how to solve equations that have a variable in the exponent. We've always solved equations, get x by itself on one side, but we've never had an x in an exponent position. This says 2 to the power of 3x minus 4. There's an x up here, right? We've never had that before. So let's follow along with the notes here and understand how to do this. It says if we have a base to a certain power equal to the same base to a certain power. See, you have a base 2 here and a base 2 there. If you have that situation where the bases are the same, then those powers must be equal to each other. This 3x minus 4 has to be equal to 5. If these numbers are the same, these guys have to be the same. They have to be equal to each other. In other words, you could ignore or delete the base of 2. You could delete these 2's, and these exponents come down to form your nice simple equation. Does that make sense? Now check this out. Let's go to something super basic. If I had 2 to the third, I know that the answer is 8, but let's not put an 8 there. Let's say 2 to the third equals 2 to something else. What does that something else have to be? What does this have to be?
A 3.
It has to be a 3. There is no way 2 to the third is going to equal 2 to the fourth. There is no way 2 to the third is going to equal 2 to the second. Right? The only way this is true is if you have a 2 here and a 2 there, if you have 2's right there, the same exact base, then these exponents have to equal each other. So that's where this rule comes from. So like if I had 2 to the third equals 2 to the x, and I tell you solve for x, you could just scratch out those 2's, and the exponent 3 comes down, and the x comes down, and that's your answer, x equals 3. Yeah? Okay, that's how it works. That's how easy it is.
What if it was just like...
Let's go back to our notes so we don't get too lost here. And that actually answers your question. It says you can do this only when you have the same base on each side of the equation. So right here you have a base 2. Right here you have a base 3. You can't do it right here. Okay? Right here you have a base 2. Over here you have a base 2. But there's also this plus 6, and that messes it up also. The only way that you could scratch out, like up here, the only way that you could scratch out this 2 and this 2 is if they're the same exact base, same exact value, and there's nothing else. You can't have a plus 3 out here. You can't have a times 5 over here. It has to be the same exact base.
So then how does that one work with the 6?
So the one with the 6, you'd have to solve it a different way using logarithms. But we're not in Algebra 2, so we're not going to do that yet. We're not going to worry about that right now. We're not going to see any of those. But definitely in Algebra 2, you're going to have to apply logarithms to solve those. But maybe towards the end of the year, we'll get to that. So here's a key concept for today, guys. I hope everybody understands. When you have a variable in the exponent position, try and manipulate the bases so they could become the same base. So right here you have 2 to a certain power equals 32. The only way I could scratch out the bases is if they're the same exact base. So up here it says to manipulate the bases so they could become the same base. In other words, could I change this 32, could I change it to become 2 to a certain power? And you guys could use your calculator if you want. 2 to what power gives you 32? If you go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I could rewrite 32 to be 2 to what power? 5th. Come on, guys. I just did it, right? 2 to the 5th power is 32. So I say, I explain what I just said right here. The only way you could get rid of the variable down, get the variable down from the exponent position is to manipulate the 32 to become a base of 2 to a certain power. Try it. So we said this 32 is going to become 2 to the 5th. So let's rewrite it. We're going to have 2 to the 3x minus 4 equals 2 to the 5th. And now that you have those 2's right there as the same base, you could just scratch them out because we know that this guy has to equal this guy. So what does that mean? We're going to have a new simple equation, 3x minus 4 equals 5. Okay? And let's solve it. Plus 4, we'll get 3x equals 9. Divide by 3, divide by 3. you're going to get x equals 3. And there's your final answer for this above equation. X has to equal 3 in order for this equation to remain true. Okay? So you want the same base. You want, if this is a 2, you want this 32 to be a 2 to a certain power. If this were a 3, you'd want this to be 3 to a certain power. Okay? You want the same base on both. So if you understand that concept, we need to try this first practice problem. Now, in order for us to be able to do this, you need a calculator. That's why I asked you guys to get a calculator. So what we're going to do is use the calculator to be able to change this number to be 3 to a certain power, right? So on your calculator, if you have the Casio, it's pretty easy. You want to find out what 3 to a certain power gives you that huge number. Type in 3, and then there's this button right here. It's x to a certain power. You type in that button, and on your screen, you should see this. 3, and right here is where you're going to type in whatever number you want. Now, obviously, 3 to the third is 27. This number is way bigger than 27, so don't put a 3 right there. Guess at it. What could you put in there? 7? So what do you get when you put a 7 in there? 3 to the 7th power. That's the answer? Okay, so if you type in 7, you'll get that exact answer. So let's rewrite it. We have 3 to the x equals 3 to the 7th. So what could you do now with those bases? Scratch them out. What's your answer? X equals 7. Done. Now, if you have a Texas Instrument, because we don't have all Casios, if you have a Texas Instrument, yeah, these are a little bit outdated, but all you would do is type in the number 3 and then hit this button. It's the caret button. And the next number that you type in after that, that would be an exponent. This is making it an exponent. This button makes it an exponent. So when you type in 3 and then this caret and then guess at it, 3, this, and then 5, that would give you a number, but it's not big enough. 3, caret, 7, that'll give you the number that we have over here, 2,187. Okay, so it depends which calculator you end up with on the test. You need to be able to use both of them. So this is actually a very easy section, and this is actually a huge part of the test next week. So you guys should enjoy this section because it's so easy compared to the other ones. Let's take a look at number 2. Now, ladies and gentlemen, I need both of these bases to be the same. So I need to change this to be a what? A 3. Go for it. Get a calculator and try to figure out 3 to what power will give me 243. So on the calculator, I'm going to go 3 caret 4. That's 81. It's not big enough to give me 243. If I go 3 caret 5, that gives me 243. So what I'm going to do is rewrite the 243 as 3 to the 5th power. I didn't think about it. I did it with the calculator. Figured it out with the calculator that 243 is really 3 to the 5th. Now that we have the 3 right there and the 3 right there, now we could do the x plus 3 up on top. I could take this x plus 3 up here and this 5 up here and create a new equation by scratching out the 3's. You have x plus 3 equals 5. So yes, the answer is 2 when you subtract 3 and subtract 3. X equals 2. Okay. Let's move on to the next one, number 3. Okay, what do we want this number to become? A 6. So everybody, with a calculator, figure out what power belongs right there to give us 1,296. And then once you figure that out, it's just guessing and checking with the calculator. Once you figure that out, you'll be able to get rid of those 6's and create a new simple equation. So 6 caret 4. Yeah, 4 works. All right. If you go 7, you're going to get a huge number. So then you know you got to pick something smaller than 7. 6 to the 7th was too big. You keep plugging and chugging until you get the right answer. So 6 to the 4th is what worked. So we really have an equation that's going to read x minus 3 is equal to 4. Again, it's going to be the power equaling the other power. These bases, you could scratch them out, erase them, make them disappear. X minus 3 equals 4. And when you solve that, what do you get as a final answer? 7. X equals 7. Too easy to mess up on. And you're like, what? 65,500? So what? You're not even going to think about it. You're just going to use a calculator, right?
Oh, I got it.
4 to what power? 4 to what? 4 to 8? 4 to the 8th power? So 4 to the 8th power, using a calculator. 4 to the 3rd, it's too small, obviously. 4 to the 5th, 4 to the 7th. You see that those numbers are too small. If you go 4 to the 9th, it's too big. You go 4 to the 8th, you'll see that it does give you 65,536. So what we really have is 4 to the 3, let me do it in blue, 3x minus 4 equals 4 to the 8th. Now that we have those same bases as 4, we could erase the bases and the equation becomes 3x minus 4 equals 8. And to solve that, you're going to go plus 4, and you'll get 3x equals what? Which means that when you divide by 3, x equals 4 as the final answer. Let's move on. What do I need that 4,096 to become? 2. So you need to go 2 to what? 2 to the 3rd power? Heck no, that's 8. You need something way bigger than that.
12.
12?
Yeah.
All right. Some of us are pretty fast at using calculators. 13? 2 to the 12th? 2 to the 13th?
It's 12.
Yeah, if I try 2 to the 13 on the calculator, I get 8,000, not 4,000. So that's too big. So 2 to the 12 is the correct number. 2 to the 12th power is going to be equal to 2 to the 4x plus 4. Of course, the 2's you're able to delete. Your new equation becomes 4x plus 4 equals 12. And you're going to solve this thing by subtracting 4 and subtracting 4, which means we have 4x equals 8, which means that your final answer, if you divide by 4 on both sides, x equals 2. So there's a huge portion of the test that's on this stuff. So we should be able to do all right next week, especially because we haven't even practiced yet. We're going to practice today, practice tomorrow, practice on Monday. There's a lot of practice. You guys should be able to ace this next test. Now this last one,
That makes like no sense.
it doesn't make sense because I can't change 81 to become 27 to the 2nd power. It's too big, right? So we're stuck unless we were able to manipulate both numbers to be the same base to a certain power but just different powers. In other words, could I rewrite 27 to be something to a certain power?
Yes.
What? 9 to the 2nd power? 81? No.
7.
Okay, so 3 to the 3rd power gives you 27, right?
Yeah.
So if I rewrite 27, why did that happen? If I rewrite 27 as 3 to the 3rd, I still have the power of x minus 1 out there. And maybe I should put it in parentheses instead of a box. That doesn't make sense. Parentheses is better. Could I rewrite 81 to be 3 to a certain power?
3.
3 to the 4th power
Wait, why 3?
is 81. Why 3? Because I know I have a base of 3 right here. So it'd be nice if I could change this one to be a base of 3 also, right? So now that we do have the same base 3's, we could eliminate them and solve what's left over on the exponents. However, on the exponents, I have a power to a power. So I have this 3 times the binomial x minus 1, which you're going to have to multiply 3 times x, that's going to be 3x, and 3 times 1, that's going to be a minus 3 instead of a minus 1. Of course, this 3 and this 3 disappear. Your new equation is going to have a 4 on this side. And we will get an ugly answer. It's going to be a fraction, but that's okay. Let's continue solving here. We're going to add 3. I'm going to have a new equation that reads 3x equals 7. And my final step will be to divide by 3 on both sides. Divide by 3 here, divide by 3 there. X equals 7 over 3.
2.32.
Or you could say 2 1/3. But anyways, that's the answer. So if you understand this, that's great. We just need to practice more. And we're going to do our homework to practice that. Keep in mind, guys, about half of the test is right here on the class opener. Okay, half of the test is on the class opener. Watch the previous video if you want to refresh your memory on the class opener. The other half of the test is right here, solving these types of equations and rewriting and stuff like that.